Good morning, students. Today we will start the new chapter, lesson 15, polymers. Now, the term polymer is derived from the two Greek words. Poly means many and mer means parts and unit. There are a large number of the molecules having high molecular masses, vary from 10 to the power 3 to 10 to the power 7 unified mass, and hence they are also known as a macromolecule. As we all know that the polymers are the backbone of the modern civilization, because polymers are extensively used in the manufacture of plastic, buckets, cup, saucers, children's toys, packing bags, synthetic clothing material, nylon, terylene, furniture, automobile parts, tires, seals and electrical insulating materials. As we know that the process by which the monomers are transformed into polymer is known as polymerization. Now, the polymer or the macromolecule or the high molecular masses or the substances, each molecule of which consists of very large number of simple repeating structural units which are joined together through the covalent bond in a regular fashion. The simple and the reactive molecules forms, which are the repeating structural units, are called the monomers, and the process by which the monomers are transformed into polymer is known as polymerization. Depending upon the nature of the repeating structural units, the polymers are divided into two categories. One is homopolymer and other is copolymer. Now, in homopolymers, the polymers whose repeating structural units are derived from only one type of monomer unit, then it is known as homopolymer. Example, ethene on polymerization form polyethene. While in case of copolymer, the polymer whose repeating structural units are derived from two or more than two type of monomer unit, then it is known as copolymer. Now, the classification of the polymers on the different bases. Number one, the first classification of the polymer is based on the basis of origin. On this basis, the polymers are divided into three parts, that is natural polymer, semi-synthetic and synthetic polymers. Natural polymers are those which are found in the nature, in animals and plants, are called the natural polymer. Example, proteins, polysaccharides, nucleic acids, natural rubber are the examples of natural polymers. Semi-synthetic polymers, those which are derived from the natural polymer by chemical modification. Example, cellulose on acylation with acetic anhydride in presence of concentrated sulfuric acid gives cellulose diacetate, which is known as the artificial silk or rayon acetate. Third is known as the synthetic polymer. A large number of the man-made polymers are used in our daily life. Example, nylon, polyester, plastic, rubber, etc. all are the synthetic polymers. Next, the classification of the polymer on the basis of the structure. First is linear polymer, second branch chain polymer, and third is cross-linked polymers. Now, linear polymers. In these polymers, the monomers are joined together to form the long straight chain. These long straight chains or the polymers, they are closely packed over one another, and due to this very close stacked structure of the polymeric chains, they have high density, melting point, boiling point and tensile strength. Example, high density polyethylene and polyvinyl chloride. Second is branch chain polymers. In this polymer, the monomer units not only combine to produce the linear chain but also form the branches of the different length. These polymer chains does not allow the main chain molecules to come close together. As a result, they have low melting point, density as well as tensile strength. Example, amylopectin and glycogen are the example of branch chain polymers. Cross-linked. Now, in these polymers, initially formed, the linear polymer chains are joined together to form three-dimensional network structure. The three-dimensional network structure are developed due to presence of the cross linkages. These polymers are also known as cross-linked polymers. These polymers are hard, rigid, brittle. Example, bakelite and melamine formaldehyde polymer. Now this is the classification of the polymer, which is based upon the intermolecular force of attraction. Now the first is elastomers. Now what do you mean by the elastomers? In case of elastomer, the polymer in which the intermolecular force of attraction between the polymeric chains are weakest, then we use the word elastomer. Elastomers are amorphous polymers having high degree of elasticity. These polymers consist of randomly coiled molecular chain of irregular shape having few cross linkages. These are known as van der Waals force of attraction. Due to the presence of the van der Waals force of attraction, they are able to develop the elastomer polymers. Example, Buna S, Buna N and neoprene. In these polymers, we will observe that they are the solid rubber-like polymers having high degree of elasticity in them, and the polymeric chains held by the weakest intermolecular forces. These bind forces permit the polymer to be get stressed to the 10 times of their initial length. And the cross linkages are developed between these chains. Second is fiber. What of fiber? Fiber are the polymer in which the intermolecular force of attraction are the strongest. Then we call them as fiber. These forces are either due to hydrogen bond, dipole-dipole interaction in the molecules of the polymeric chains. And due to this strong intermolecular force of attraction, fibers have high tensile strength, high elasticity, and the molecules of these polymers are long, thin, thread-like, and hence can easily be packed. And result, they will have high melting point and low solubility. Next is thermosets. Thermosetting polymers, these are semi-fluid substances with low molecular masses which when heated in a mold undergo a permanent change in the chemical composition to give the hard, infusible and insoluble masses. This hardening of heating is due to extensive cross linkages between the different polymer chains and give the three-dimensional network of the solid. Therefore, in case of thermosetting polymers, we are having examples of bakelite, urea formaldehyde resins, and they cannot be reused again and again due to the development of extensive cross linkages. Now the fourth is thermoplastics. Now thermoplastic polymers in which the intermolecular force of attraction are in between those of elastomers and fibers. Then we call them as thermoplastics. These are the linear or the slightly branched long chain molecules capable of repeating softening on heating and hardening on cooling. These polymers possess intermolecular force of attraction intermediate of elastomers and fibers. Example, polythene, polystyrene and polyvinyl chloride. Now the classification of the polymer that we are observed already on the basis of heating, that is thermoplastic and thermosettings. Now this is the types of the polymer and polymerization, classification of polymer structure, polymerization mechanism. 9 polymer structures we are having: condensation polymer, addition polymer, and step polymer and the chain growth polymer. This is the polymerization mechanism, step growth and chain growth polymerization that we will study later on. Now the fourth classification, that is classification of the polymer on the basis of the mode of polymerization. First is addition polymers and second is condensation polymers. Now in addition and condensation polymers are formed by the repeated addition of large number of same or different monomer possessing double bond or triple bond and the process by which the addition polymers are formed is called the addition polymerization. Example, ethene changes into polyethene, propene changes into polypropene. The addition polymers can be either addition homopolymer or addition copolymer. If we see the formation of Buna S, the addition polymer which is formed by repeated addition of two or more type of monomer units, then they are called addition copolymer. Buna S is formed by the polymerization of 1,3-butadiene and styrene. And in case of condensation polymers are formed by the repeated condensation reaction between two bifunctional or trifunctional monomer units, usually formed with the elimination of the small molecule like that of water, alcohol, ammonia, carbon dioxide and hydrogen chloride. And the process which condense the polymers are called the condensation polymerization. Example, nylon 6,6, which is obtained by the condensation polymerization of the two monomer unit, that is hexamethylene diamine and adipic acid.